Good afternoon, friends. Welcome to Get Class Lecture 4. So, many times we discuss about the weightage of each course or each subject is also important. So, one of the important subject which can be solved easily and which can be known somewhat straight questions in water resource engineering also. So that prepared like this. First of all, hydrology, engineering hydrology. The engineering hydrology includes the hydrologic cycle first. The three important phases in hydrologic cycle is the operation, precipitation, runoff. So apart from rainfall, precipitation in the form of rainfall is the main concentration is on rainfall only. So how to measure the rainfall, how to calculate the average rainfall, what is normal rainfall, what is effective rainfall. This is the important for attempting the 1 mark questions. Then data is missing in each station. So using two methods, average method, normal ratio method. So after that, the runoff may be classified as three types: surface runoff, subsurface runoff, base flow, or groundwater flow. So if you separate the base flow from the total runoff, you are supposed to get direct runoff. This is important. So the direct runoff related to effective rainfall. What is the hydrograph? So hydrograph is a relationship between the discharge and time. But the use of hydrograph. So by seeing hydrograph, you can easily know about the hydrological conditions of the area, so that the ultimately you are supposed to use for the design of irrigation structures. So anything, whatever the topic and whatever the hydrograph concept or whatever the groundwater hydrology, whatever it is, the ultimate aim is it can be used for to design the structures. So hydrograph is a relationship between the discharge and time. Then unit hydrograph refers to it's a direct runoff hydrograph resulting from 1 centimeter effective rainfall. So, for example, direct runoff hydrograph resulting from 5 centimeter effective rainfall. 5 centimeter effective rainfall, the ordinate of direct runoff hydrograph, for example, 100 meters per second. For say for 1 centimeter, so for 1 centimeter, 100 by 5. This is the ordinate of unit hydrograph. So then what is the use of unit hydrograph? So it is simply already many times I discussed that. For example, 200 meters per second discharge, unit hydrograph, it can be shown as maybe 10 meters per second. So like that, your scale conversion, that's all. So that's the use of unit hydrograph. So where is are already applications of unit hydrograph already discussed. Then the important topic of groundwater hydrology. In groundwater hydrology, main is discharge through aquifers. So that's 4 definitions: aquifer, aquifuge, aquitard, aquicube. These are all the important. So one which may contain water and transmits water, one which may contain water, not transmit water, neither contains water, not transmits water. That's all. If you classify these things, you're able to remember the definitions very easily. So discharge to aquifers, confined or unconfined. So two formulae, Dupit's equation. That is important. So coefficient of permeability is also coming into picture. Then coefficient of transmissibility is a product of coefficient of permeability into thickness of the aquifer. So that is the important. Now, next, design of lined and unlined canals, headworks, gravity dams, and spillways. So this was a one question chance to ask in the gate examinations also. It may not include problems, only theory questions, but straight questions, just to concentrate direct material also itself more than sufficient to attempt in gate examination also. So let us see the topic of canal irrigation system, alignment of canal, distribution system. Alignment means construction, that's all. How to alignment of canal and how to select the route of the canal. Then distribution system means how to distribute main canal, branch canal, major distributary, minor distributary, and field channel. So there are two silt theories are there because of while designing the canal, two silt theories are developed: Kennedy's theory and Lacey's theory. So then design on lined irrigation channels. Of course, lined irrigation channels may not important now actually. But the thing is, we are concentrated on unlined canals. So using Kennedy's theory and Lacey's theory. Lacey's theory is very important than Kennedy's theory for GATE examinations as well as in other competitive examinations also. Then types of linings. What is lining actually? So for example, canal bed and sides are protected with impervious material. It's called lining of a canal. Then concept of gravity dams. So what are the forces acting on a gravity dam? So combination of forces for design, then modes of failure and criteria for structural stability of gravity dam. Because of what are the causes of failures and what are the remedial measures. So of course it is useful for your current semester as well as GATE examination. Please utilize the same. So if you see the canal irrigation system, so you know alluvial soils, right? Same alluvial canals means the soil which is formed by the agency of water. Agency of water means transport of water. That's all. Over a course of time is called alluvial soil. So the canal which passes through soils is called alluvial canals. Right? Alluvial soils, alluvial canals. Then non-alluvial canal. In mountain regions, on hard rock foundation, canals or rivers may pass. These type of canals will not create problems like change its course. These are called non-alluvial canals. Just opposite that, that's all. Then alignment of canal, if we see watershed canal. This is a picture. There is a stream, right, or river flowing through. So what is meant watershed actually? Watershed is a line which divides the catchment of two different drains. If the canal is aligned on a watershed, it's called watershed canal. So cross city works means cross drainage works. Cross drainage works can be avoided in this type. Water can be taken both sides. So where the cross drainage is necessary actually, when the two stream and canal is passing and cross at one point, you are supposed to consider cross drainage works. So canal is flowing above the ground level, drain is flowing below the canal, or drain is flowing above the canal, or both at passing at the same level. These are three important. One is aqueduct, one is super passage, third one is level crossing. So here, if the canal is aligned on a watershed, it's called watershed canal. So next is contour canal. So you know contour. What is not a contour? Actually, general term. The lines of joining the equal levels, equal reduced levels in a map is called contour. In like this, contour canal also alignment of canal along the contours. It is suitable in hilly areas. That's all. Then side slope canal alignment right angles to the contours. In distribution system, so see the order of distribution system. Please remember this actually. So main canal, branch canal, distributions, minor distributary, then water course or field channel. So the canal flowing starts from main canal, you know. So the branch canal takes off from the main canal. Then major distributary, minor distributary. Then water is supplied to the field channel. That is the sequence. So shear stress tau naught equal to gamma W into R. Yes, that is general formula. So S equal to bed slope, R equal to hydraulic mean depth, right? Or hydraulic radius. That's equal to area through wetted perimeter A by P. So gamma W equal to unit weight of water. So what is the equation for Manning's formula? V equal to 1 by n R power 2 by 3 S power half. Of course, it's already studied in fluid mechanics also, just for recollecting. So Cherry's formula V equal to C into R into root RS. So in case of regime canals, silting and covering, these are two important. Silting means formation of silts. Covering means sides are breached. So when you use the Cutter's formula for calculation of V, this is Cutter's formula. Just recollect that's all. 1 by n plus 23 plus 0.0155 by S by 1 plus 23 plus 0.00155 by S into n by root R into root R into S. So then lined and unlined canals. Unlined canals are stable, you know, because of one lining is completed. Bed and side slopes are protected with some impervious material like concrete, bricks, etc. So it is stable one. In case of unlined canals, the sides are not protected because of the earthen canal. If flood comes, there may be a chance of damage to the canals. So that unlined canals are unstable. Silting and covering not occurred mostly in case of line canals. So covering and silting occurs many times in unlined canals. So while designing line canals, Manning's and Cherry's formula are used for design, whereas design of unlined canals, silt theories, Kennedy's theory and Lacey's theory. So what's meant by Kennedy's theory? So Kennedy done the research on upper body dope canal system. So it's remember that because of which canal the research work is carried on Kennedy. So upper body dope canal. So eddies will form and eddies will not allow silting. So that is silting equal to severing. So there is a formula V equal to 0.55 Y power 0.6. So some textbooks is also use M. So what is M or what is Y, whatever it is. So whereas V naught equal to meter per second, Y equal to depth of flow in meters. So Kennedy's design a critical velocity, this one 0.55 m into y per 0.64. Some textbooks D is also used, let us say C, D or Y. So now V by Vk by V naught, right? Here, critical velocity on the region Vk by V naught, it's called critical velocity ratio, CVR. CVR equal to critical velocity ratio. So there is a formula used to calculate the velocity in case of Kennedy's formula, that is Cutter's formula. And it is important. Lattice theory is very important both in university examinations as well as in GATE examination also, and various competitive examinations also. So lattice theory, first of all, lattice developed a regime theory. It's called a theory called a regime theory. So regime means stable or equilibrium. So there are three types: true regime, initial regime, final regime. Right? Initial regime is not a channel in regime. So true regime. Let us say first. So Q is constant, its flow is uniform, silt charge is constant, silt grace is constant, silt is incoherent alluvium. These are the characteristics of true regime. So then initial and final regime is when only the bed slope of canal, channel or canal channel varies and its cross section or wetted perimeter remains unaffected. See, cross section or wetted perimeter remains unaffected. Even the channel can exhibit no silting, no covering properties called initial regime. So initial regime, final regime, true regime. So if there is no resistance from the sides and all the variables such as perimeter, depth, slope, etc. are equally free to vary and finally get adjusted according to discharge and silt grade, then the channel is said to have achieved permanent stability called final regime. So these are the various formulae. You have to remember that. It's a very interesting also. So what is F? The lacy is taking into consideration of silt factor F. That's equal to 1.76 root D or some textbooks MR, whatever it is a mean particle size in mm only. If root D only mm, if mentioned in the other units, you are supposed to convert it to millimeters only. Then only this formula is applicable. F equal to 1.76 root D in mm, D equal to mean particle size in mm only. Then P equal to mean velocity of flow, V equal to Q F square by 140 whole power 1 by 6 meter per second. So the relation between the P and Q, P equal to 4.75 root Q, right? Then SFQ relation, S equal to F4 5 by 3 by 3340 Q power 1 by 6. So scour depth R equal to 1.35 Q square by F whole power 1 by 3. So the formula for calculating average velocity V equal to root 2 by 5 FR. Now it's not 2 by 3, it's 2 by 5, right? 2 by 5 FR. So according to correct it, of course that I will correct it, I will send it. V equal to root 2 by 5 FR. So according to Lacy's theory for a level reverse, regime bit W equal to 4.75 root Q. For design of line irrigation channel, it may not syllabus also. It. Then types of lining. So what are the types of lining? So already told you that what is meant by lining means lining of canal includes the sides and bed are protected with some impervious material. It's called lining of canal. So one is hot surface lining. In that concrete lining, so protected with concrete material, shotcrete or plaster lining, so brick tile or concrete tile lining, then asphaltic concrete lining, boulder lining. So earth type lining means compacted earth lining, soil cement lining. So this is a brief theory about the canals or design of canals. So in design of canals, we have to concentrate on Kennedy's theory and Lacy's theory, right? The important is Lacy's theory, the various formula that you have to remember. Then gravity dams. So already what is meant by gravity means they are self-weight, that's all. So a gravity dam has been defined as structure which is designed in such a way that its own weight resists the external forces. So that's why it's called as a gravity dam. So why dam is called as a gravity dam is you have to straight away give the answer like that. So the gravity dam is designed in such a way that its own weight resists the external forces. So it's a major hydraulic structure constructed across a reservoir to develop a huge storage of water behind it. The highest gravity dam in the world is Grand Distance Dam in Switzerland. It's a famous dam. It still continues its records, 285 meters. And Prerana Dam in India, 226 meters. Next to the dam is the second highest dam. So what are the forces acting on a gravity dam? First one is water pressure. Because of the water is stored in the reservoir, that gives us a water pressure. So this is that water distribution is triangular in shape. Bottom P equal to WH. So the area of the triangle of BH of into bottom gamma W into H into H. That's gives gamma W into H square by 2. And it acts as a H base from the base or from the bottom. This one. So this is a gravity dam of height H. This is a maximum water level. This is so water pressure. Let's say P acts at distance of H base from the base. That is included. So then the upstream phase is partly vertical and partly inclined. So sometimes this one. So upstream phase is partly inclined, partly vertical. Sometimes like this also. Maybe full vertical or partly vertical. So the resulting water force can be resolved into horizontal component and vertical component. So this is like this. This is a gravity dam. So first one is water pressure, then uplift pressure. So uplift is due to one is water table, the second one is soil conditions. So the uplift pressure intensities at the heel and the toe should be taken equal to their respective hydrostatic pressure and joined by straight line in between. So when drainage galleries are provided to relieve the uplift, the recommended uplift of the paste gallery is equal to hydrostatic pressure. So like this actually. So these are the gravity dams cross sections. Then one is earthquake force also, silt pressure, then wave pressure. So these are the and ice pressure. Then important weight of the dam also, right? Then combination of forces are there. So these are the various forces acting on a gravity dam. Please list out one by one actually. First one is, let's list out various forces acting on a gravity dam. Force acting on a gravity dam. One is water pressure. Second one is uplift pressure. Third, earthquake. Right. Fourth, silt. 5, wave pressure. 6, ice pressure. Then weight of the dam. That's all. So the design of gravity dam should be checked for two cases. One is when reservoir is full, then reservoir is empty. Actually, when reservoir is empty, only it's a dangerous condition actually. If reservoir is full, there is no problem, strictly speaking. So that how it is will be discussed later. So what are the modes of failure and criteria for structural stability of gravity dam? So overturning or rotation, it is a ratio of resisting movement about toe to the overturning movement. So it's called factor of safety against overturning. So how much factor of safety is 1.25? This please remember this value. The factor of should be always greater than 1.25 against overturning. Then second one is compression or crushing. So this is the one. So maximum stress sigma v by b into 1 plus 6 e by v less than or equal to f, so that it is safe. Then tension. So for known tension developed at the base, middle third rule. So equal to b by 6. That's mentioned here. So this is where its factor of safety is adopted for design. So in case of no overturning condition, clockwise movement equal to anti-clockwise. That is not important actually. The base width of the gravity dam b equal to h by root s minus c. This is important. So this form is important. B equal to h by root s minus c. See some questions actually. The dimensions of Manning-Sen. So Manning-Sen actually it is though it is a constant, but it has dimensions. How it is actually? Let us see. V equal to 1 by n r power 2 by 3 s power half. So what is V? Velocity, distance by time, L by T equal to 1 by n into R equal to in meters, because of hydraulic radius R equal to A by P in meters, L to the power 2 by 3, S is bed, so no units. So if you get n equal to L power 1 by 3 into T. So that's it's here, asking here, right? Answer is A. Critical velocity V naught equal to 0.55 m into y power 0.64. So the depth of flow in an alluvial channel. What is meant alluvial channel actually? Alluvial soil. So the flow in a channel is through alluvial soil is called alluvial channel. So the depth of flow in alluvial channel is 1.5 meters, y equal to 1.5. Critical velocity ratio CVR, right? V by V naught equal to 1 by 1, and Manning's n is 0.01, right? The critical velocity of the channel as per the kinetics method. So you know critical velocity V naught equal to 0.55 m into y power 0.64. As it is substitute 0.55 m equal to 1.1. What is meant by m? Critical velocity ratio 1.1 into y 1.5 0.7 meter per second. So this is see straight problem. Find the velocity in meter per second in a canal according to Lacey's theory. If silt factor is 1.1, discharge is 50 meter per second. So discharge Q equal to 50 meter per second. F equal to silt factor already given. If not given, using the formula F equal to 1.76 root MR or D in mm only. So using that formula V equal to Q F square by 140 whole power 1 by 6. So substitute directly Q equal to 50 meter per second. Then F equal to 1.1 whole square by 140. That will give it like this. See, the lazy silt factor for a particular alluvium is 2.0. This alluvium would comprise so medium size of sand 0.5 mm, right? Coarse sand of size 0.75 mm, medium budget of size 1.3 mm, coarse budget of size 2.4. How to get actually F equal to 2 here? Because of 1.76, F equal to 1.76 root MR. So F equal to 1.76 root MR or D in mm, substitute 2. So if you get particle size, D equal to 1.3 mm. This is some of the question that I will share you. So now this is one of the from this chapter also one or two questions asking. So design of fierce and permeable foundations. So Bryce creep theory, Lane's weighted creep theory, Kosla's theory, critical exit gradient, then uplift pressure at key points in elementary cases, correction for thickness of floor and sloping floor. So the subsurface flow below a weir. So what's meant weir actually? Weir is a construction, barrage is a gates alone. So the subsurface flow below a weir causes two definite instability problems as below. One is uplift forces due to the subsoil pressure that tends to lift up the barrage of flow. So it is due to the uplift condition. So second one is upward rising seepage forces through the river bed just downstream of the solid apron causes sand particles to erupt upwards and tends to piping failure of the foundation. So for these two developed a theory, Bryce creep theory and Koslov theory. For that, no need to remember this. Only thing is, remember this one, that's all. Seepage length or total creep length L equal to L1 plus L2 plus 2D1 plus 2D2 plus whatever it is, like this. See the figure. Creep length is like this. This one, this, the root, that's all. That you can study. I will send the materials and you can prepare like this. So now this is one. These are one of the important topic. So every gate examination, one question is asking from this. So types of irrigation system, irrigation methods, then reclamation of waterlogged and saline soil, causes and control of waterlogging. So what are the types of irrigation? So irrigation may be broadly classified into surface irrigation because of supply of irrigation is surface only, surface irrigation, subsurface irrigation. So in surface irrigation, flow irrigation, again flow irrigation, perennial irrigation, flood irrigation, then lift irrigation. Then subsurface irrigation, natural sub-irrigation, artificial sub-irrigation. So if you see the irrigation methods, free flooding. So the name itself indicates flooding to the crop freely. So this method is also known as irrigation by plots. Is commonly used in India. The field is divided into a number of small sized plots which are practically level. The size of plots depends upon the porosity of the soil. So there is a free flooding normally practiced by the farmers. So then next one is water strip method. It's a low investment method. So in this method, the farm is divided into a series of strips like this. So the lengthwise slopes very fly like this. So that so these are dependent on four factors. One is size of irrigation stream available, infiltration rate of soil, longitudinal slope of the land, then length suggested for moderate conditions. That you may know to remember like these values also. So see the check flooding like this. So check flooding and basin flooding and zigzag method. These are the various methods. If you see the diagram also, this is very easy to remember. Just you draw and remember the diagram. Just one question is asking from this diagram only. Definitely. So first one is irrigation methods, surface, subsurface, sprinkler, right? Surface irrigation, flooding, furrow, contour farming. Subsurface, drip irrigation, trickle irrigation. So again flooding, while flooding, controlled flooding. So in controlled flooding, free flooding, contour laterals, border strips, checks or levees, basin flooding, zigzag method. That's all. If you remember this diagram, one question is definitely asking in the gate. Just this diagram only. So what is meant by waterlogging actually? If you see, waterlogging occurs due to seepage. So for example, your village, we have a tank. So if you see tank is filled, in surrounding fields, always moisturized. So that condition is called waterlogging. See, when the groundwater table moves in the upward direction, comes closer to the ground level, that is within a 1 to 1.5 meters below the ground level area, is said to be waterlogged. So an agricultural land is said to be waterlogged when its productivity gets affected, definitely because of always in water, crop gets affected. So by the high water table, if root zone is plant gets flooded with water, air will not be available to plant root zone and reduces yield. This is called waterlogging. So then the plant requires nutrients like nitrate, sand, right? These are found by aerobic bacteria. So if air is not available, bacteria will not survive. So that no food for plants results less yield. These are the effects of waterlogging. So due to waterlogging, salts will be accumulated in the root zone and these salts become saline. Then what are the remedies actually? Waterlogging, there is no, because of the land, some of the land situated nearby tank, so there is an alternative. There's a waterlogging effect is there. So but to overcome the waterlogging, these methods are adopted. Over and intensive irrigation, seepage of water from adjacent highlands, seepage through the canal. So impervious obstruction, inadequate natural drainage, inadequate surface drainage, excessive rains. So these are the reasons for waterlogging. Submergence due to floods, irregular or flat topography. So how to control the waterlogging means lining of canals and water courses, because if you line the canals, so there may be chance of reducing seepage. So then reducing intensity of irrigation, because of if you are supply the irrigation, for example normal plants, if you give irrigation 10 days once, so in these plants we are supposed to give once in 20 days like this. So that is reduce the intensity of irrigation. Introducing crop rotation. So you have to rotate the crop. Optimum use of water. You have to use less of amount of water. Whatever required, we are supposed to supply. Providing intercepting drains. Provision of efficient drainage system. Improving the natural drainage of the area. Introduction of lift irrigation. So these are the remedies to be taken to overcome the waterlogging. Then efflorescence. So the phenomena of salts coming up in solution and forming a thin crust on the surface after the evaporation of water is called efflorescence. So the land is affected by the efflorescence is called saline soils. So what is meant by leaching? So leaching is a process. The land is flooded with adequate depth of water. So the alkali soils present in the soil gets dissolved in this water, which percolates down to join the water table or decline away by subsurface drainage. This is called as leaching. See, sprinkler irrigation system is suitable when, see, option A, the land gradient is steep and the soil is easily erodible. B, the soil is having low permeability. See, the water table is low. D, the crops to be grown have deep roots. See, below 3 reasons may not relevant because of sprinklers are used. The topography of the land is very steep because we have to move the sprinklers place to place. If you know, so the suitability is like this. So the right answer is A. So which of the following methods of applying water may be used for on rolling terrain? So water flooding. Then lift irrigation. What is lift irrigation? What is flow irrigation? Flow irrigation is flows due to gravity. Lift irrigation is flows due to not gravity by pumping. So let's say already from lower level to higher level. So what required from lower level to higher level is pumping is required. So lift irrigation is flow from lower level to higher level. Then, so last topic, canal regulation works, cross drainage structures, outlets, and escapes. It of course that in the second chapter or second semester also you may have the syllabus, but see just outcome, just outline we will discuss, not in depth. So canal falls, canal regulators, so metering flumes, and canal outlets and modules. So what is meant by canal regulation works? The mainly called as CR works. You know, the canal regulation means the works carried out to adjust the levels of the canal bed level and general ground level. So the works which are constructed in order to control and regulate discharges, depths, velocities, etc. in a canal are known as canal regulation works. But these structures ensure the efficiency functioning of canal irrigation system by giving full control upon the canals. So the important cause of these structures are due to canal falls, canal regulators, metering flumes, canal outlets and modules. First one is what is meant by canal fall. So already I discussed it. Canal falls are where necessary to falls are provided actually. So canal falls are solid masonry structure which is constructed on the canal if the natural ground slope is steeper than the design channel bed slope. So due to this reason, the falls are provided at various locations. So if the difference in slope is smaller, single fall can be constructed. If it is higher than falls are constructed at regular suitable intervals. So location of canal falls. So location of canal fall depends upon the following factors. One is topography of canal, the economy of construction or filling, because of cost also involved in that. So the important types of falls which were used in olden days and those which are being used in modern days are also described below. There's Ogi falls, rapid falls, stepped falls, trapezoidal notch falls, well type falls, simple vertical drop falls, straight places falls, Montague type falls, English falls, or baffle falls. Then canal regulators. So the name itself indicates regulation, means regulate. So it includes the distributary head regulator and cross regulator structure for controlling the flow through a parent canal, and it is take off from the distributary. So when main canal is flowing, the water is supposed to take off from the main canal. Right? The regulation works are necessary. So that's why it's provided for in that location. So canal regulators are helps to maintain the water level in the canal and the upstream of the regulator. Distributed head regulator and cross regulator. So a distributed head regulator controls the supply of the off-taking channel, while a cross regulator consists the supply of the parent channel. See, remember that one more questions. So cross regulator controls the supply of the parent canal, whereas head regulator controls the supply of the off-taking channel. So see the difference between the cross regulator and head regulator. So head regulator provided at the head of the off-taking channel controls the flow of water entering this new channel. So while cross regulator may be required in the main parent channel, this one, downstream of the off-taking channel, and it's operated when necessary so as to head up the water on its upstream side. So that to ensure the required supply in the off-taking channel, even during the periods of low flow in the main canal. So these are the flumes. You know the flume is measuring the discharge also. The emitting flume is an artificial fluid section of the channel, which can be utilized for calculating discharge in the channel only. So it's venturi flume and standing wave flume. Then canal outlets. So what is meant by canal outlet? Outlet means the farmers are sometimes used to draw the water from the main canal. So the structure is provided to draw the water from the canal. It's called outlet. So a canal outlet or a module is a small structure built at the head of the water course as to connect it with a minor or minor distributed channel. Next one is the control and maintenance of the entire network of canals. up to the module falls under the jurisdiction of the state government, like this. So the module is thus connecting link between the government and the cultivators. So already we discussed. The outlets play a very important role in controlling the flow of water at different areas, so as to affect an equitable distribution of available water in accordance with the needs of the whole area. So what are the requirements actually? The model should be fit well to decide the principles of water distribution. So if the supply is to be fixed in accordance with the cultivable area, for example, 10 acres of rice is there. So what are the requirements of water according to the crop requirements? Only you are supposed to supply. So like that is mentioned here in accordance with the cultivable area commanded by the outlet. So the outlet must be able to pass constant and fixed discharge. So the model should be simple so that it can be easily constructed by local masons. So the outlet should be cheaper since they are required in large numbers. It should work efficiently with a small working head. It should be efficiently strong with no minimum parts. So it should draw its fair share or silt. So it's a requirement of a good module. So non-model models, semi-models, and rigid models. 3 R's. So these are the various definitions that we'll study then. So this is also very, very important. Types of cross drainage works, CD works. Canal regulation works, CR works, cross drainage CD works. So the drainage water intercepts the canal can be disposed of in either of the following ways. So already we told one canal and drainage is passing. So by passing the canal over the drainage, right? So now here canal is flowing over the drainage. This may be accomplished either through aqueduct or siphon aqueduct. Second one is canal is below the drainage, right? That means drainage is passing over the canal. It's called super passage or canal siphon. So both are at level, same level. That may be level crossing or inlets and outlets. Understand? One is canal is flowing over the drainage. Drainage is flowing over the canal. Both are at same level. Let's say aqueduct and siphon aqueduct. So in this works, the canal is taken over the natural drain. Right? Canal is flowing over the drain such that the drainage water runs below the canal, either freely or under siphoning pressure, whatever it is. What is the advantage of to flow canal above the drain? Actually, inspection purpose is very easy. So that's why it is mentioned here. When high flood level of the drainage is sufficiently below the bottom of the canal, so that the drainage water flows freely under gravity. So the structure is known as an aqueduct. So sometimes high flood level of the drain is higher than the canal bed, and the water passes through the aqueduct barriers under siphonic action. So the structure is known as siphon aqueduct. So super passage, the name it is super means the drain is passing over the canal. So in this works, the drain is taken over the canal such that the canal water runs below the drain, either freely or under siphon pressure. So already it mentioned here, when full supply level of the sufficient below the bottom of the drain trough, so that the canal water flows freely under gravity, the structure is known as super passage. Again, if the efficiency of the canal is sufficient above the bed level of the drainage, so that canal flows under the siphonic action under the trough, the structure is known as canal siphon. So then level crossing. So in this type of level crossing, so the cross drainage work, the canal water and drain water are allowed to intermingle with each other because of its same level. So level crossing is generally provided when a large canal and huge drainage approach each other practically the same level. So then what is inlet and outlet? So an inlet is a structure constructed in order to allow the drainage water to enter the canal and get mixed with the canal water and thus to help in augmenting the canal supplies. This is called inlet. So such a structure is generally adopted when the drainage discharge is small and the drainage crosses the canal with its bed level equal to the canal full supply level. So in the inlet, the drainage water is simply added to the canal. So that is called inlets and outlets. Let's see the small question. The gated regulator, which is construction in the parent canal near the site of an off-taking canal, is called cross regulator. In case of distributed canal, it's called distributed regulator. So it's a parent canal, cross regulator, distributed canal, distributed head regulator. But a cross regulator helps in increasing supply in the off-taking channel, increasing water depth in the parent canal upstream. So coastal laws theory applicable VSN barrages, cross regulators and head regulators, then modules, both. Right? So both VSN barrages, cross regulators and head regulators. So the channel construction to bypass excess water entering a canal is called canal escape. The siphon activated, the worst condition of uplift of the roof occurs when the canal is empty and drainage is flowing full. See, this question is a IAS examination. Actually, what is meant by activated actually? So the canal is flowing above the drainage. Siphon means FSL drainage. So this see observe level area. It's a canal data. It's a drainage data. Its flow canal means 5 meter per second, whereas in drainage 500 meter per second. Bed level 120, here 112. So difference is 120, 112. This is higher than this level. Depth of its 0.8 and 0.10. So when bed level is of the canal is above, right? Drainage is below. Definitely it's aqueduct. But here the whole explanation is here. No, canal bed level is higher than drainage bed level. It's no doubt it is aqueduct, but HFL of the drainage above the canal bed, high flood level, is above the canal bed level, so that siphon aqueduct is provided. So by next class, I will send it the material also. After completion of only one class, I am left. So we'll send the material also. Just a minute.